This is section 2.1, power and radical functions. This is part B of the section. So for this part, we're only going to do the second I can statement. You should be able to graph and analyze radical functions and be able to solve radical equations. A radical function is a function that can be written as the nth root of x to the p power, where n and p are positive integers greater than 1 that have no common factors. So if we write this exponentially, it would be x raised to the p over n power. If you write it as a radical, it's the nth root of x to the p. So whatever your denominator is in your exponential, that can be what's in front or on top of that root when you write it in a radical form. So we need to graph and analyze the function. We're going to describe its domain, range, intercepts, end behaviors, continuity, and where it's increasing and decreasing. So if we graph this, our graph looks like this. So our domain, if you look from left to right, it does start where x is equal to 0 and continues for the right to infinity. So our domain is 0 to infinity, including 0. So that's a square bracket. The range starts at y is equal to 0 and continues to infinity. So the range will also be 0 to infinity, including 0, which means you have the square bracket. The intercepts for this, we have one intercept right here. And it is crossing the x-intercept at 0, and it's crossing the y-intercept at 0. So we can say our x-intercept is 0, our y-intercept is 0. The end behavior, the graph starts or begins at x is equal to 0, so there is no left end behavior. But on the right end, you can see it's continuing up forever, so it's going off to infinity. To determine if a graph is continuous, you see if you can draw the entire graph without having to pick up your pencil. Now it does not continue on to the left, but for all values of the domain, the graph is continuous. So we say for all values of domain, the graph is a continuous function. And if we look at the graph, it is continuing to go up, so it's increasing from 0 to infinity. An extraneous solution is a solution that does not satisfy the original equation. Whenever you're solving radical functions, it's always important to plug your answers back in to check to see if they are extraneous solutions. So we need to solve the equation. When you're solving a radical, you want to get everything that is not inside the radical on one side and just have the radical on the other side. So we are going to take that 2 to the other side. Right now it's negative, so we're going to add it to the other side. So that will give us 2x plus 2 is equal to the square root of 100 minus 12x. Now to get rid of that square root, we're going to do the opposite. This is the square root or the second root. And the opposite of that is raising it to the second power or squaring both sides. So on the right side of our equation, that square and the square root will just cancel each other out. And you'll just be left with 100 minus 12x. But on the left side, that is now a binomial times a binomial. Because 2x plus 2 squared is the same thing as writing 2x plus 2 times 2x plus 2. We're then going to use FOIL on the left side of the equation. So we're going to do first, which is 2x times 2x, which is going to give us 4x squared. We're going to do outside 2 times 2x is going to give us 4x. We're going to do inside 2 times 2x will give us 4x. And we do last 2 times 2 gives us 4. When we combine like terms, it's going to give us 4x squared plus 8x plus 4 is equal to 100 minus 12x. Since we see we have x squareds and x's, we're going to take everything to one side, and then we are going to factor. So when we take that 12x to the other side, we're going to add it. So 8x plus 12x gives us 20x. That 100 is positive, so to move it to the other side, we need to subtract it. And 4 minus 100 does give us 96. Now you can factor it when it's in this form, or we can divide everything by a 4 first and then factor, because all of those values are divisible by 4. If we divide by that 4, it will make our factoring a little bit easier. So 4x squared divided by 4 just leaves us with x squared. 20x divided by 4 is 5x. And 96 divided by 4 is 24. Now we can factor. We need to see what multiplies to get x squared, which is x and x. We want to see what can multiply to give us negative 24. Then when we add it, it gets a positive 5. So a positive 8 times a negative 3 will give us a negative 24, and 8 minus 3 is equal to 5. So we have factored it correctly. The last step is we're just going to take each of our binomials and set them equal to 0 separately, and then solve for x. So on the left side, we're going to be left with x is equal to negative 8. On the right, we have x is equal to 3. Now these are both possible answers, but you do need to make sure you substitute them back in to make sure neither one of them are an extraneous solution. So if we plug in negative 8, 2 times negative 8 is going to give us a negative 16 on the left. Negative 12 times negative 8 is going to give us a positive 96. 100 minus 96 is 4. The square root of 4 is 2. And 2 minus 2 is, 2 minus 2 gives us 0. Since 16 does not equal 0, we know that x does not equal negative 8. We do the same thing if we plug in 3. We have 2 times 3 is 6. 12 times 3 is 36. 100 minus 36 leaves you with 64. The square root of 64 is 8, and 8 minus 2 is equal to 6, so the left side does equal the right side. So our only solution is x is equal to 3. With this equation, we're going to start the exact same way. Get everything that is not attached to the radical to one side, keep the radical on the other. So right now we have a positive 14. If we take that to the right, 50 minus 14 is going to leave us with 36. Now on the left side of the equation, we have the cube root, or the third root of a function. To get rid of that cube root, we do the opposite. So we're going to cube both sides of the equation. And this will leave us with x minus 5 squared is equal to 46,656. Now we need to get rid of that square. So we're going to do the opposite of squaring, which is to take the square root. Remember, anytime you take an even root, so 2, 4, 6, 8, 10, when you take an even root, you have positive or negative. When you take an odd root, third, fifth, seventh, you don't have to worry about the positive or negative. So if we take a square root of both sides, on the left side, you're just left with x minus 5. On the right side, you do have plus or minus 216. Now we're going to set both of those equal. So we're going to say x minus 5 is equal to a positive 216, and x minus 5 is equal to a negative 216. We are going to add 5 to both sides. And we're going to get x is equal to 221, or x is equal to negative 211. Make sure you remember to plug both of those back in to check for any extraneous solutions. Both of these actually do work, so we do have 2 answers for this problem. Let's look at one last example. On this one, there is a radical on both sides of the equation, so you can't get everything with a radical on one side and everything that doesn't have a radical on the other. We're just going to have to solve it the way it is. So we are going to start by trying to get rid of the square root that's on the left side first. To get rid of that square root, we are going to square both sides. So when we square the left side, that square is just going to cancel our square root. We're just left with x minus 2. On the right side, we have a binomial squared, and a binomial squared just means you can write that binomial twice, and we're going to multiply. So we have 5 minus radical 15 minus x times 5 minus radical 15 minus x. Now, for the purpose of this problem, let's think of radical 15 minus x as just a variable. So treat that as you would treat any x or any y. When you multiply, you can square it if there's two of them, or you just put a number out in front of it. So we are going to FOIL. So we have 5 times 5, which is 25 for our first. Outside, we have 5 times a negative radical 15 minus x, which is going to give us a negative 5 radical 15 minus x. On the inside, we have 5 times negative radical 15 minus x, which again will give us negative 5 radical 15 minus x. And last, negative times a negative does make it a positive 15 minus x squared. Now if we combine like terms, and if you notice we have a squared radical, so that squared with a radical will cancel. So we're going to be left with x minus 2 is equal to 25 minus 10 times radical 15 minus x. It's 10 because there was 2 of 5s, so 5 and 5 gives us negative 10. And plus 15 minus x, because remember we squared that radical, and so that canceled and just left with us a 15 minus x. If we combine like terms again, we will be left with x minus 2 is equal to 40 minus x minus 10 times radical 15 minus x. Now we just have one radical, so we're going to get everything that doesn't have a radical on the left side. Everything that is inside the radical will stay on the right side. So we're going to take the 40 and subtract it to the other side. We're going to take that negative x and add it to the left side. So that'll leave us with 2x minus 42 is equal to negative 10 times radical 15 minus x. Now we need to get rid of that radical, so we can square both sides of the equation. On the left side, now you have a binomial squared, so again we can write that, the binomial twice, and then FOIL. On the right side, you're just going to square each piece separately. Negative 10 squared is going to give you a positive 100. And the square root of 15 minus x, that squared will just get rid of the square root, so you're just left with 15 minus x. On the left side, we're going to FOIL again. So first, 2x times 2x gives us 4x squared. Outside, 2x times negative 42 gives us a negative 84x. Inside, negative 42 times 2x gives us a negative 84x. And last, negative 42 times negative 42 is going to give us a positive 1,764. If we distribute on the right, that's going to give us 1,500 minus 100x. Now we need to combine like terms. If you notice, we have x squareds and x's, so we're going to take everything to the left side of our equation. So we're left with 4x squared minus 68x plus 264 is equal to 0. Again, we can divide everything by 4, so it makes it easier to factor first. So we see what multiplies to get x squared. We have x and x. We want to see what multiplies to get a positive 66 that will add to get a negative 17. Negative 11 times negative 6 will give us a positive 66. And negative 11 plus negative 6 is a negative 17. Now we just set each equal to 0. And we solve for x. On the left side, you're going to get x is equal to 11. 11, not 10. On the right side, you're going to get x is equal to 6. Once again, make sure you plug them back in to make sure you will not get extraneous solutions. But in this problem, both answers do work.